what we're going to look at then is geometric sums, but this time they go on, the series go on forever, but they come to a specific value. So Sn once again represents the sum of the first n terms. Now in this case we can actually rephrase that. It represents the sum of infinite terms because it goes on forever. And T1 is the first term still. R is your ratio still. Now there's a new thing, and this is really important. This rule only works if the absolute value of R is less than 1. In other words, if it's a fraction or a decimal number, then it works. It could be a negative fraction or a negative decimal, but it cannot be greater than 1. It's got to be somewhere between 1 and negative 1. If that applies, then you're in good shape. Okay, so we can use that formula. Now, why would that be? Well, let's think about it. All right, so let's go ahead and put this to work. Go ahead and write down number 1, please. So, to use this formula, notice the top here has this little sideways 8. We might know by now that means infinity. So it's going from 1 to infinity. Luckily, we don't need to plug infinity in. You can't do that. Infinity is not a number. It's a concept. So all we need, though, is T1. We need R, and that's it, right? So the formula for an infinite geometric series looks like this. Okay? So let's find out what T1 is. Well, T1 we can get by plugging in 1. 1 minus 1 is 0. And anything to the 0 power is 3 times 1 would be 3. So my first term is 3. Now R, what's my R? You can see it because it's being raised to the n minus 1 power. It's 1/3. I'm using that little shortcut we talked about earlier. You can just tell by looking at it because it's in that right format. All right, so all we got to do is plug it in. So the sum of the infinite terms is 3 over 1 minus R, and R is? 1/3. Okay, so what is 1 minus 1/3, guys? It's 2/3. We did some problems like that back when we were doing our probability. You just subtract these two, like 3 minus 1 is 2, so it's 2/3. Now, how the heck do we do that? Well, let's go back to semester 1 when we talked about rational expressions. This is really saying 3 divided by 2/3, right? So how do I simplify that? Keep, change, flip. Keep, change, flip. And then multiply straight across. So 3 times 3 is 9 over 2. 9 halves. Now, let's do it. I'm gonna mess with you guys here a little bit, okay? I'll tell you when. I want you to write with me, but there's gonna be a point where I'm gonna say don't write. Okay? Here we go. T1. Well, you can see it, right? It's 1. And what is R? Well, we got to divide the second term by the first term, so 3 over 1 is 3. And that's all we need for an infinite geometric series. How do I know it's infinite? Notice how it just has dots here, and there's nothing at the end of it. Well, that just means it's going to keep going on forever. So let's do it. So the sum of the, now this is where I want you guys to stop writing, okay? The sum of the first infinite numbers is T1 over 1 minus 3, which is, okay, so whoopity-doo, we're done. That's a false answer. Does somebody know why this is a false answer? That's right. Remember, to use the infinite geometric series rule, R, the absolute value of R, has to be less than 1. And is the absolute value of 3 less than 1? No. So we are not allowed to use this formula. And if we're not allowed to use that formula, what that means is this series does not converge, which means that since it's getting bigger and bigger, it actually just goes off into infinity. It never stops getting bigger. So the answer to this is infinity. It doesn't stop. It just grows too fast, too big, too much.